For each of the following graphs, decide which function is shown, quadratic, exponential, or neither, and explain why it is that type of function. So part 1, I see that this is a parabola. So I know that a parabola is quadratic. So this is quadratic because it's a parabola. Part B looks kind of like a parabola, but it's like a V. So this is neither exponential nor quadratic because it looks like a V. And we've actually learned what this is. This is absolute value. This last one, I see that it starts flat and then it gets steeper and steeper and steeper. So this is exponential. For each of the following sets of points, find the domain and range and then decide if the relation is a function. So let's see, the domain is the x values. So here we've got 3, 5, 1, and then 3 again. So I'll put them in order, 1, 3, and 5. The range, y equals 2, 7, 4, 7. So 2, 4, and 7. So we want to know, is it a function? So does each x value go to the same y value every single time? So 3 goes to 2. 5 goes to 7, 1 goes to 4, 3 goes to 7. Oh, this is a problem. First, 3 goes to 2, and then 3 goes to 7. This right here is the problem. 3 can only have one output, but right here it has two different outputs. So this is not a function. So x equals 3 has two outputs. Y equals 2. And y equals 7. For the second one, the domain of the x values are 6, 3, 9, 5. So I'll put them in order, 3, 5, 6, and 9. The y values are 2, 5, 0, and 7. So 0, 2, 5, and 7. Is it a function? So 6 goes to 2, 3 goes to 5, 9 goes to 0. 5 goes to 7. Yes. There are no x values that go to different y values. Here, domain x equals 1, 2, and 3. The range, 9, 7, and 9. So just 7 and 9. Is it a function? So do any of the same x values go to different y values? Well, we have none of the same y values, so yes. This is a function. And the last one, our domain is 11, 6, 7, 6. So 6, 7, and 11. And our range is 3, 5, 1, 3. So 1, 3, and 5. Is it a function? So 11 goes to 3, 6 goes to 5, 7 goes to 2, 6 goes to 3. Oh, this is a problem. Because at first 6 went to 5, but now 6 is going to 3. So this is not a function. X equals 6 has two outputs. Y equals 5 and y equals 3. Find the domain and range of each graphed function. So if this is a line, it's going to keep going forever. So we would say that the domain is all real numbers because it goes on forever and ever and ever. Same with the range. For this parabola, parabolas are going to go down forever. So the domain is all real numbers. But the range, let's see, y stops here at 2. So it goes from negative infinity to 2. Some of you may have teachers that have you just write this. Y can be any number that's less than or equal to 2. For this function, let's see, the domain, so this is going to continue on forever and ever and ever. So the domain is all real numbers. You could also write all real numbers like negative infinity to positive infinity. The range, so the y values here, every single time y is equal to 2. So here the range is just 2. Y is equal to 2. Using the table of values, find the following. So here are our x's, and then here's our y's. So f of negative 3, see that's right here. So f of negative 3 equals 2. F of 20, so when x is 20, our output is 0. F of 8 is right there. F of 8 equals 4. If f of x equals 9, what is x? So let's see. When f of x equals 9, that's right here. So x is 2. When f of x equals 0, that's right here, x equals 20. Alright, so here we got some sequences. So let's see, I want to find out if it's linear, exponential, or quadratic. So I see here I'm adding plus 5, plus 4, plus 5. This is none. So it's not linear, it's not exponential, or it's not quadratic. So to explain the rule in words, we would do, let's see, you add 4, then add 5, then repeat. So the 8th term, so let's see, if we add 4, well, we do 4, 9, 13, 18. So next we would add 4. So that'd be 22. Then we'd add 5, 27. Then we'd add 4, 31. 1, 2, 3, 4, 5, 6, 7. So here we added 4, so now we're at 5, 36. This one, I see that it's multiplying by 2. So this is exponential because it's multiplying by 2. So, explain the rule in words. Each term is 2 times the previous term. So the 8th term, so let's see, this is the first 4 terms. So term number 5, 6, 7, 8. So 48 times 2 is 196. So that's this one. Then 96 times 2 is 192. That times 2 is 384. And then that times 2 is 768. So let's see here. We're adding plus 1, plus 3, plus 5. Oh, and I see that there's a pattern here. That's plus 2, plus 2. So next we must add plus 7. So this is quadratic because the second difference is constant. And here we would say that each term you add an odd number. The number that you add is increasing by 2. So to find the 8th term, let's see, that's the 4th term. So we'll do the same thing. Make a table. So 5, 6, 7, 8. So we know that to go from 15 to the 5th term, we have to add 7. So that's going to be 22. So then we know here we're going to add 9, then we're going to add 11, then we're going to add 13. 22 plus 9 is 31. 31 plus 11 is 42. And 42 plus 13 is 55. So I notice here I'm doing minus 3, minus 3, minus 3. So this is linear because the first difference is constant. And each term you subtract 3 from the previous term. So we are at 70, so then we would go to 67, 64, 61, 58.